So next up, we're going to be talking about evaluating government policy and how there are different impacts of price controls and taxes on a competitive market model. And so we've at first discussed how do competitive market models work, and now we can actually see how policy interventions can often cause markets to diverge from the original goals of the competitive market model but can be used for other purposes. And so first we're going to talk about price controls, and that is minimum and maximum prices. So when we talk about minimum and maximum prices, we're usually talking about price ceilings and price floors. So a price ceiling and a price floor. A price ceiling is a maximum amount that something can be charged, and a price floor is a minimum amount that something should be sold for. So, for example, with farm policy, we set a minimum price for major food crops in the US, like corn and wheat, it's because otherwise the equilibrium uh, quantity would cause the price to be too low in order to sustain farmers. And so we need a price floor there to get a higher price of those goods. And then there's also a minimum wage. So labor is going to be a cost that we need to set a minimum price floor on. Other employers seek a living wage instead of a minimum wage. And then there's also New York and other cities that have established rent price ceilings. So setting a maximum price on being able to rent out an apartment. So, for example, with landlords that might want to charge a ton of money for rent, then this they've set caps on this as to prevent it being too expensive. And then additionally, another example is in 1979, the Middle Eastern oil supplies were interrupted and heating oil prices they went up significantly, and so the government decided, okay, we're setting a ceiling on these prices for heating oil in order to protect low-income families. So a lot of these are to protect lower income families or lower income, like farmers, for example, a price floor. It seems as though if a market price unfairly hurts either a consumer or a supplier, so if a market price is being too high or low, either one, then we may say, oh, we should just implement a price ceiling or a price floor. But it's it does have some social costs. So we can see in figure 16 that the competitive market is at $400 a month here. So if we look at these apartments, then we can see here is the equilibrium. And then our rent ceiling says that we cannot sell anything above this line. And so originally, if you notice, our consumer surplus was all of this here. But now our new consumer surplus is increased, but, well, actually, I'm going to go ahead. I'm going to draw this triangle. This right here is all the suppliers who are not willing to supply at a quantity above $1,900. And so all these people who would buy at a higher price point at higher than 1900 are losing their their consumer surplus. So that is known as the deadweight loss. And then here we have our new consumer surplus all the way down here because all of these consumers who are willing to pay $500 are willing to pay the $300. So we have this new. And then clearly we also have some reduced producer surplus. So this is our new producer surplus, whereas our old producer surplus was all of this, right? And so we can see that our our total surplus has decreased because we lost all of this red triangle right here. And this is known as our deadweight loss. And so that's the idea of what happens with a price ceiling. And so this just explains that, okay, we're going to also have a consumer surplus. We're going to have too many people wanting apartments. So right here, we've talked about this before. We have people demanding 2,100, whereas there are only 1,900 available. So, and there could be more people here that are getting to rent apartments and that are willing to, but we're missing out on those people because this is an overall inefficient allocation of resources. So we can see that at a competitive market equilibrium, everyone who values the apartment as much as the market price is gets to rent an apartment. However, now landlords have to choose, okay, who am I actually going to choose for my apartment? Who am I going to give it to? Am I going to discriminate and rent it to my friends or based on personal characteristics? And thus, apartments will no longer go to those people who value the good most highly, but instead, this will then produce an inefficiency. Because if it doesn't go to individuals who value it most highly, then there's going to be that inefficiency here. And so we can see that there are more negative effects of rent controls even from history. So both the supply and demand of housing in a city is relatively inelastic. It's relatively unchanging. People are see housing as a necessity, so it's relatively inelastic. And there are a relatively fixed amount of houses in a city, and thus the supply is inelastic. And so rent controls just lower the price without even um, creating too large of an excess demand. But over time, so remember that time horizon, the housing, the rent control, um, will actually become more elastic. And so this is this means that landlords may, well, so the things listed here are cut back on maintenance costs. These allow the apartments to deteriorate, and then this allows them to be removed from the housing stock. So with then a decrease in price, with a decrease in price over time, we can see that some housing developments may decrease in supply more over time, thus making it elastic with a change in price, resulting in a larger change in housing stock. And low prices will attract more residents, which will increase the elasticity of the demand. And so uh, the excess demand will become more of a problem here. Well, I actually need to clarify something that the low prices attracting more residents doesn't necessarily mean that the elasticity of the demand or the price elasticity of the demand is going to be more. It just means that there is more demand overall for this housing. And so we can actually look at now not just a effect of a price ceiling, but now we can look at a price floor. So, for example, for the market for wheat. So let's say the competitive equilibrium is at $5 a bushel. And The equilibrium uh, quantity is 100 million. So if we look here, we can see 105. But what we have here is we have established a $8 per bushel minimum price, so a price floor. And this is to protect the family farms. And so this means that the demand falls to 80 million bushels and the supply rises to 115. So we have excess supply here. And so farmers can't sell all the wheat they're producing. And so this reduces consumer and producer surplus because farmers could be supplying more wheat at lower prices, and consumers would be willing to buy at those lower prices. But they can't do that because the minimum price stops them from doing so. And so we can see once again here with this price floor, we see that there is an excess supply at 115 million bushels of wheat, and 80 is demanded. So we have an excess supply here. And then we have the consumer surplus is greatly reduced. And then we also have the producer surplus here. That seems to go up, or actually, I'm going to use a different color here so I can distinguish. We have producer surplus, and then we have all of this dead weight loss. Now, it could depend on the problem whether the producers are losing a bunch or if they're even gaining some by increasing this amount. But we can actually determine this, right, by how elastic something is. So let's say we set a price floor. We are going to know if the farmers are losing revenue through this by if the demand curve is elastic or inelastic. So let's suppose that the demand for wheat is relatively inelastic. So in that case, we know that if we go back to our previous section here, we remember that with a relatively inelastic demand, then if we go down in revenue, or if we go down in price, then you are losing revenue. So that means as we go up in price, then we are increasing in revenue. And so, although another thing to note is the surplus is also dependent on the supply curve. But if we were just focusing on revenue here, then we could see that the revenue for this, oh, let's go up. The revenue goes from this amount, right? Let's just say it's inelastic, even though it's probably not, to this amount. And so we have, if it were inelastic, we have increased the amount of revenue. However, if it was elastic, which honestly, just looking at this, you can't entirely tell. We'd have to do the math. But we can see that they're increasing in revenue. However, the main point here that they were trying to talk about is how we have seen that consumer and producer surplus are both being reduced. And another thing I'd like to shortly discuss is to see the fact that even if we were to look back at a rent ceiling here, we can see that the consumer surplus may not be um, increasing, but it can for some consumers. So because we have that deadweight loss, we only know if we were to actually calculate it. And so next we can actually talk about the next type of government intervention, and that is taxes. So government uses taxes in order to raise revenue to pay for public expenditures. And this is important in asking, okay, who bears the burden of a tax? And so uh, it seems governments can control the distribution of, okay, is it going to be suppliers or the consumers who are going to be taking on the weight of this tax? But in reality, it looks like it's not that simple to see. So if we take a look at how much a tax costs different people, let's say that cell phone costs are 20 cents per minute and consumers make 1 million minutes of calls each day. And then there's a tax of $10 per minute on consumers. So if you were to just look at this from the perspective of mobile phone users, 1 minute of talk is now 30 cents instead of 20 cents. And so we can see in the figure, if we go down here, that there is a 10-cent increase in price here. So we know that then we have 10 cents is going to the government here in our little figure. So reason that we have shifted downward by 10 cents here is if we look at this amount right here, this is the key. 10 cents, we are going to be demanding 1 million minutes. And this is because there's a 10-cent increase because of the tax. So this would really mean the real price of if the suppliers are supplying it at 10 cents, right? That means the consumers, it's going to cost them 20 cents per minute. And thus their quantity demanded will be the same as if originally they had 20 cents. And so everything shifts down by 10 cents. And so we see right here, this little triangle, recognize it? It's the reduction in social welfare here. It's that deadweight loss from the tax. And so if we go back over to taxes here, we can see that the market equilibrium is now at a lower quantity and the price received by the suppliers then it falls because people are less willing to buy. And so this affects suppliers as well. And so, like, for example, again, we see 16 cents per minute. So suppliers would receive 16 cents per minute while consumers are paying 26 cents per minute. And so it seems then that the burden of the tax is being given to both the suppliers and the buyers then, because the suppliers are losing out on the money that they would have been getting had there been no tax. And this means that the tax is reducing the equilibrium constant quantity, and so the total surplus is lower, and so we are preventing mutually beneficial exchange from taking place once again, because our equilibrium price and quantity are above where it would have been. Now, if we were to suppose that the 10-cent fee is on only suppliers, so we see that the revenue suppliers have is reduced by 10%, and so we shift the supply curve upward by 10%, or not 10%, 10 cents. So we can see this in figure C here for increasing by 10%, or not 10%, I keep saying that, 10 cents. So where we originally would have had 20 cents, we are now charging it at 30 cents as to alleviate the burden of the tax from the suppliers, because the suppliers now have to charge more because of the tax. And so now they supply it at 30 cents instead of 20 cents. And so, or even 26 cents instead of 16 cents. And so then we see that it's the exact same outcome that was on consumers. And so this this clearly then creates what's known as a price wedge. It's between the amount that consumers pay and the amount suppliers receive. And so this will reduce the market quantity, so we're going that way, no matter who pays the tax. And so we can actually illustrate how tax is represented in the next figure, where the we look for where is the vertical distance between the demand and supply curves equal to the amount of the tax. And then we see that extending a vertical line down from the price that suppliers receives and consumers pay is the equilibrium quantity now that the tax has been opposed. So we can see right here the equilibrium quantity, no matter if the burden is on consumers or suppliers, is going to be right here, where there's a 5 cent up from the equilibrium to the demand and a 5 cents down to the supply. And so our total revenue is this line that's 10 cents wide, all the way down to less than 1 million minutes. That is the equilibrium quantity now. And so we see that this stops all of those mutually beneficial transactions from taking place. It stops all of those transactions that are happening in the little triangle that we saw. So remember when I highlighted the little triangle, make it red. This is all of the producers and consumers who would have been able to have a mutually beneficial exchange, but alas, could not. And so we can see that this little triangle is called the deadweight loss. I already went over that. And so the other effect of this tax is that there's going to be revenue that's collected by the government. And so if 10 cents per minute is purchased at the new equilibrium, this is shown by the little rectangle that's shaded. Let's say people initially talked 1 million minutes, but the tax of 10 cents per million or per minute, it actually generates less than $100,000 because 10 cents times 1 million is $100,000. However, if we look, it's going to be less than that because we don't get all of that shaded um shaded triangle originally. We are at a lower quantity. And so the revenue the government receives, it reduces the combined consumer and producer surplus from these actions by an amount that's let's underline this real quick. That is equal to the income that the tax produces for the government. And so the combined consumer and producer surplus from the transactions is equal to the, or sorry, the reduced combined consumer and producer surplus is equal to the income the tax produces for the government. So, for example, it walks us here through if suppliers paid 40% of the tax and buyers paid 60%, in general, the distribution of the tax, it all relies on the price elasticities. So if something is less elastic, then it's going to have a greater share. Or for a supply curve, if the supply curve is less elastic, then the greater share of the tax is going to be paid by the buyers. And then if we take a look here at this figure, then we can see that a lot more of the burden is going to weigh here as it says, or less elastic the demand for any given supply curve. Apologies. If you have less elastic demand, so say you have your demand curve that's like this, your burden is going to be more the less elastic it is. And then we can also see that the elasticity of supply also affects the division of the tax as well. So a less elastic supply means more burden on the producers. And so, however, with the less elastic supply and demand curves, if we have less elastic, so that means, remember, a bit of a steeper slope, then we actually have less dead weight loss. So let's actually illustrate this through these figures because it might be kind of hard to visualize. So in our original equilibrium here, let's say we have the 10-cent little burden that we were talking about here. So let's say we go from just about here to here, right? So that's our 10-cent tax. And so we have our deadweight loss, and then we have the revenue that the government is generating. And so if we have this new burden here where it's less elastic demand, I'm actually going to do a different color here. Less elastic demand would mean right here that we have less dead weight loss because this triangle here is smaller than the original one because we have less elastic demand. And the same goes for over here if we're looking at our original burden, or our original burden looks like this. This is it. And we have the dead weight loss right here. I'm going to do it in red. Versus our new dead weight loss would be something like this. And we have our new tax. But as you can see, the burden goes more upon the producers because it is less elastic and more flat, or more upward going, it seems. Thing I'd like to go back to here is looking at, okay, well, what is the consumer and producer surplus reduction? Well, it's this tax revenue right here that we talked about earlier. So if that statement may have been confusing, if we're looking for the total reduction in just total surplus here. So remember what the producer and consumer surplus were. It was all of the area here for the produce or for the consumers, and then all of the area right here for the producers. And so we reduce it by all of this tax revenue right here. And something of note is that this revenue, if we go ahead and just write down here, the revenue is going to be equal to the equilibrium price, or it's not going to be equal to, it's actually going to be, well, less than or equal to the equilibrium price times equilibrium quantity. And see, the problem here, I'm going to make this time symbol a little more clear. The problem here is that we have this little red triangle that is being lost. And so, or we actually have a little less than that. It's the outside of where the triangle would be. And so, let me better explain this by erasing all this messy work. We can see this little amount and this little amount is not being collected, right? And so, even though we have, or not the equilibrium price, apologies. This is going to be just the tax amount. So the tax times the equilibrium quantity, but we aren't getting all of the all of the stuff we could be getting because our new equilibrium quantity is below 1,000,000 minutes. And so we're losing a little bit of this. Now, remember, this actually depends on the elasticity again of the price and demand. So if we have a lower elasticity for demand and supply, then we're actually going to be losing less revenue. And this is why the revenue can range of less than or equal to the tax times the equilibrium quantity. Because if you have both perfectly inelastic demand and supply, and then you do the tax burden, well, then you have just a perfect rectangle where you can do, okay, 10 cents times the equilibrium quantity, which is 1,000,000, which is 100,000. And so we see here that the elasticity matters here too. And so now that we understand that, we can begin to talk about international trade. So we're going to start by seeing what actually makes people better off. And a lot of this is exchange in general is going to make people better off, which is called gains from trade. And so if individuals or countries or whoever is producing something, they choose, okay, we're going to make what we make best, then overall, everything that's possible to make, it's going to increase in amount. And this is called gains from trade, where the overall economic pie, as the packet says, is increasing. And so we need to first look at an isolated economy, and then we can see how this alters well-being in a market. And so if we look at an isolated economy, we see Robinson. He is stranded on a desert island. So he's just, or a tropical island, apologies. And he can work 8 hours a day no matter what. And he's like, okay, I'm going to produce some food because I need to eat. And so he can either harvest coconuts or he can catch fish. Now, I personally would probably prefer to catch fish because I like fish more than just eating coconuts. And so he has to choose, okay, am I going to gather coconuts or am I going to catch fish? 1 hour that Robinson is gathering coconuts for, he doesn't spend catching fish and so forth. So this is opportunity cost. So the opportunity cost of getting additional coconuts is the quantity of fish he would have been able to catch during that hour. And so we can see Robinson faces what's known as a production possibility frontier, or PPF, shown in figure 20a. So I'm going to show you what a PPF looks like in figure 20a. We can see that in this PPF, where he could produce 24 coconuts, or he could produce 8 fish, or he could, for example, produce, let's do an easy one, 12 coconuts and 4 fish, or maybe whatever else you have. And so we can see that going along this curve shows all the different possibilities of trading off a coconut for a fish or a fish for a coconut. And so Robinson has to make this choice of what is he going to give up. And so the PPF, we see that the amount of coconuts that he can gather is on the vertical axis, and then the number of fish is on the horizontal. So if he spends all 8 hours of a day just collecting coconuts, he can collect 24. Whereas if he spends all his time catching fish, he can catch 8 fish. And so this this shows this is the distance that the from the origin from each point. So this is just once again being able to being able to read a graph and see that the vertical axis is going to tell us how much coconuts we're producing, and then how the horizontal is going to show us how much fish. So we see here. And so we can see that selecting any point, we can see that there's a straight line, and the slope of this line shows the opportunity cost of coconuts in terms of fish. So remember, slope is change in y over change in x, which would be the change in amount of coconuts per fish that you have. And so with a slope of -3, we are giving up 3 coconuts for every additional fish that we produce. So I'm going to go ahead and scroll down again and show you with every additional fish that we produce, we are going to go down by 3 coconuts. So this is 3 and this is 1. So let's say we go from 16 to 0. So that would be a reduction here. Actually, it's a bad example. Let's do 18 to 0 so that we have a reduction in 18 coconuts results in an increase here of 6 fish. So we've increased by 6 fish. And so we can see how the slope impacts the opportunity cost of coconuts. So how much coconuts are we giving up in order to produce a fish? Now, Robinson could have different preferences on, okay, does he value fish three times as much as he does a coconut? And so we can see that um, he just has to select any combination of these two amounts along the PPF for this to be uh, maximizing his satisfaction relative to his preferences. But any allocation along that line, that PPF, is going to be efficient because we are producing as much as we can. And so we can see that if we are considering Robinson to be a rational consumer, then we know that he'll get just as much pleasure from one more fish as from three coconuts. It's equal weight here because he can produce that amount. And so he can't improve his well-being anymore, and therefore we are Pareto efficient. And so if one fish gave him the pleasure of two coconuts, then reducing he could reduce his consumption of fish by one and increase his consumption of coconuts by three. And so taking only two coconuts to compensate for the fish he has given up, he would be better off. So let's just say he values then the fish, this is saying, not as much as the coconuts. He doesn't give him the value of three coconuts, it gives him the value of two coconuts. And so if he were to reduce his consumption of fish, he would be better off. But in this case, if he were to go along the PPF, then he would not be better off because it's just the same. And so I think the key idea here is that the pieces along the PPF that a consumer has, let's see, drawing it this way. Yeah, this way is going to be efficient. So I think a better example of how this is working is he can get the same pleasure from two coconuts as he would have originally from getting three coconuts. So if he increases his amount by three coconuts, he's better off because he would have settled for two coconuts as opposed to the three coconuts. So now we can look at another productions possibility frontier, and that is Crusoe, where she gathers coconuts and fish. So we can see in 20B, let's analyze her PPF here, where she can produce 36 coconuts or 36 fish. And so, oh my goodness. So if we can go all the way down here, if she can catch either 36 fish or gather 36 coconuts, which since she can gather more fish and more coconuts, this means she has an absolute advantage in both. So, absolute advantage is when you can produce more of the good just in general than another person. You have an absolute advantage. You have the higher number that you can produce. Her slope then is also -1, and so she will value one fish as one coconut is as in one coconut. So she can initially consume 18 fish and 18 coconuts at point B labeled right here. So 18 and 18. And so then they meet up, Robinson and Crusoe. And if they agree to trade, they can see that they'll both be better off. And so Crusoe at first isn't sure how this would work when she produces the absolute advantage than Robinson. However, at the moment, they are producing 33 coconuts and 21 fish. So Robinson was producing 15 coconuts and 3 fish, and Crusoe was producing 18 coconuts and 18 fish. And so if Robinson decided to gather just coconuts, Robinson could get 24. And then if Crusoe decided to spend a little more time fishing, then she could produce 9 coconuts and 27 fish instead of 18 and 18. And so if we add up 24 and 9, that's going to be 33 coconuts, which is the same, and 27 fish, where Crusoe is producing more fish than before, but they have the same amount of coconuts. So they're better off overall because they're, as a combined total, producing more fish. And so if they split this extra, then they could increase their consumption. So we can see right here, um, I'm going to illustrate it here. So we right here had 15 and 3. And then right here, we had 18 and 18. If, however, Crusoe chose instead to produce 9, 9, and 27, and Robinson produced 24 and none, then we add up those numbers, we get uh, 24 plus 9 equals the amount of coconuts, 33, and then 0 plus 27 equals 27 fish. So coconuts and fish. And so we see that 3 plus 18 is only 21, whereas now we have 27 fish that we can produce. And thus, if they split it and trade, they will be better off as a whole with trade. And so, how can we how can Crusoe be made better off by trading with Robinson? And so, it doesn't matter who's producing more absolutely, so absolute advantage, but actually it matters the comparative advantage. So what is the comparative advantage? The comparative advantage is whoever has the lower opportunity cost to produce a good. So let me say that again, the lower opportunity cost to produce a good. And so the idea is respective comparative advantage for their own amounts. And so Robinson faces only a cost of 1/3 of a fish per coconut that he chooses to harvest. So for every coconut, there is going to be only a 1/3 decrease in fish. Whereas with Crusoe, with every increase in a coconut, Crusoe loses 1 fish. So the comparative advantage here goes to Robinson because Robinson here is only giving up this tiny portion for a much bigger increase in coconuts, whereas Crusoe is giving up one whole fish for every one whole coconut. And so we can even see this if we go ahead and create a chart here. So let's create a chart of Robinson and Crusoe's possibilities of production. So we're going to go, this is Crusoe, this is Robinson, and then this is coconuts, this is fish, this is, or sorry, we've got Robinson and Crusoe, and then we've got coconuts and fish. And so, I'm gonna make it a different way because that makes it a little easier. And I'm gonna make it a little easier to see on you guys. So let's say this is Robinson, and then this is Crusoe, and then this is fish and coconuts. Okay, so we know that Robinson can produce uh 8 fish or 24 coconuts, and Crusoe can produce 36 or 36. Now, if you were given a chart like this, how might you find the comparative advantage and the absolute advantage and so forth? Well, I'm going to teach you here. So we see that Crusoe has the absolute advantage in fish and coconuts because this number 36 is bigger for both than Robinson's 8 and 24. But if we go ahead and look, what does it cost to make a fish? Well, we know that it costs 3 coconuts for every 1 fish. So the opportunity cost of producing 1 fish is 3/1 coconuts. Okay, so you take this number and divide it by this number, or you take the other number and divide it by the original, for example, fish, and you get your opportunity cost. And then for this one, for 24, we do the opposite. We take 8 over 24 is 1 over 3. Because 8 divided by, or 24 divided by 8 is 3, and 8 divided by 24 is 1 over 3. So the opportunity cost of 1 coconut is 1/3 of a fish. Whereas Crusoe, 36 divided by 36 is going to be 1. And then 36 divided by 36 is 1 here as well. So the comparative advantage in coconuts is given to Crusoe because, or not in coconuts, in fish, because Crusoe only has to give up 1 coconut for every fish produced, whereas Robinson has to give up 3 coconuts for every one produced. And so we can see this if we look. When Robinson specializes in producing coconuts specifically, and Crusoe specializes in producing fish, we can see this increases their total production. So Crusoe needs to specialize in producing fish because that's what she has the comparative advantage in. And then Robinson needs to specialize in producing coconuts because that's what he has the comparative advantage in. And remember, the comparative advantage is just the opportunity cost. And so, or it's just based on the opportunity cost. And so we can actually see gains from trade allow individuals, and eventually we're going to extend this now to nations, and how trading partners, if they have different comparative advantages, then they can specialize and choose to trade in the bigger market. So we looked at the idea of just a couple people, but if we look at an entire nation, for example, when we become specialized, different groups of people will have different benefits of that trade. And so, even though the gains overall are more than the losses, those who experience the losses are likely to oppose the freer trade. And so let's take a look at in an isolated economy if where international markets are prohibited because trade is prohibited and only the nation is allowed to function with its own markets. But so this would mean that the equilibrium is at the intersection of the country's supply and demand curves. Remember, just like in the little figure down here, 21A. So right here. But we can see the world price is above where the equilibrium is. If This would mean that the consumer surplus is the sum of A and B, and then producer is C. So we can see that here, right here in figure 21A, A, B, and C. A plus B is consumer surplus, C is producer. We've been over this. However, if we're finally allowed to trade with other countries and this country becomes an exporter, then the it because the cost of the supply is below the world price, then we become an exporter. Now, if the cost of supply is above the world price, then we would become an importer. We would be importing goods from out other nations. But we're looking in this case if it's higher than the equilibrium quantity. And so we can see that the equilibrium quantity will occur where the world price intersects the country's market supply curve. So if we're looking here, we see the market supply curve intersects the world price right here. So this is the quantity that is able to be sold. And so we now know that at the world price, the domestic consumers will reduce their consumption from the equilibrium quantity of the national consumption. But the uh, difference between the domestic consumption and the quantity supplied is exported. So this means that the consumer surplus is falling because the price rises, and so the consumers purchase less overall. And so the consumer surplus is represented by A. However, producer surplus is marked B, C, and D. So producers benefit and consumers suffer. So let's just illustrate this still through this little chart again. We see that the consumer surplus is now here because the world price is now here. However, the producers get all of this extra surplus here because they're able to sell at this price, or even if they were willing to sell at a lower price, they get all of that extra. So total benefits increase. So we know that if the world price is above the equilibrium quantity, then we are an exporter and producers benefit and consumers will suffer. Whereas social welfare as a whole will be A plus B plus C plus D now, where there's that new increase. But if a country becomes an importer, then social welfare increases again, but consumers benefit while producers lost. So it's basically the opposite. So we see that the in the original equilibrium, here is our consumer surplus, and here is our producer surplus right here. And then in our new with trade, importing, importing allows the consumers to benefit more. So all of the consumer surplus is now here. and the total social welfare has increased, and then producer surplus has decreased here. And so we know the quantity is going to have increased, the quantity imported. And so we can see how that affects. And so in the next video, we'll be able to explore the profit motive and how the behavior of firms is related to all of this. So thank you for watching.